All right, hello, ladies and gentlemen. Today we're talking about pre-calculus skills F10 and F12, and this is in the exponentials and logarithms unit here. You're going to be solving exponential equations using common logarithms and natural logarithms. So just so you know and remember, because we've done this, the common log is the common log button on your calculator, log base 10, and that is just the log button on your calculator. And then the natural log is the ln button on your calculators. The Casio has it too, your common log, log base 10, and natural log ln. And using those two buttons on your calculators is really, really handy. You're going to need your calculators, and if you don't have a calculator, then Desmos.com is a good place to go to do an online calculator. And we're also solving log equations using the one-to-one property or properties of logs. So we had a few properties of logs, and I wanted to remind you that if you have a log plus a log, then you want to condense it. Using the product property, which allows us to multiply u times v together. If you have a log minus a log, again, you want to condense it, and that subtracting the logs, we're allowed to condense it into a quotient, a little division, top divided by bottom, u divided by v. And so wanted to refresh your memory on those. We are going to look for that, but mostly you need to know how to use your calculator. So example 1. Solve round to the nearest thousandth. And again, I do want to remind you that IXL is going to require you to show some work. You need a place to do work, whether it's on paper or if you create your own little whiteboard using a sheet protector and a piece of paper, is a good thing. You need some paper out to do some of this work. We want to round to the nearest thousandth and make sure whenever you're rounding, it is at the end of the problem, not a minute before, only at the end. If you round at the beginning, you're going to get it wrong because you're going to have round off error. So make sure you round at the end. Right now, this is an exponential equation because the x is in the exponential. It's in the exponent position, and because it's way up there in that elevated position, we have to do something to bring it down. And the thing that allows us to drop a power is actually the power property. We can take a log of both sides. And you can take a log, you could take a log or a natural log. It turns out it works the same. So I'm sorry, I don't know why I did take a log. In class, we did it with natural logs. I said, just take a natural log. It works all the time. You can take a log also. You'll get the same answer, and I'll show you on the calculators. So if we take a log of both sides, then our power gets to drop down in front. So the natural log of 2 equals x times the natural log of 3. And that was the power property of logarithms, which I didn't talk about before. And I just need to isolate x. So I'm going to go ahead and divide both sides by the natural log of 3. The natural logs do not cross out. They're not numbers. They are functions. And this is where you go to your calculator and you type in the natural log of 2 divided by the natural log of 3. And we get a great decimal for x. And they said thousandths, so that's going to be, let's see, tens, hundreds, thousandths. So you go to the third decimal place, it's a 0. We look to the right. We go to the 10,000th spot. If that number is 5 or more, we round up the thousandths. So since it's bigger, this is going to be 0.631. So please be careful when you do that on your calculators. Now, I do want to point out, because later it's going to tell you to take common logarithms. It doesn't matter if you take a natural log or a log. They're the same thing. So I can actually take a common log of both sides, and it has the same effect of dropping the power. So the problem looks exactly the same. X times the log of 3. And if I want to get x by itself, we're going to divide by the log of 3. Now, why do I always do a natural log? That's right, you guessed it. I'm lazy, and I would rather write 2 letters instead of 3. So the only reason, ladies and gentlemen. So once again, log of 2 divided by log of 3. And we get, you can see the exact, oh, you can't see. You can see the exact same decimal because they are equivalent. So same thing. So whether you use a natural log or a log technically doesn't matter. It's kind of nice. All right. Over here, letter B. Before we can take a natural log, we have to isolate the base and its exponent. So always, always remember that you need to isolate first. And so I need to move this 2 to the other side. E to the 2x equals 23 plus 2, which is 25. And now I need to do something to drop my power. And what does that? A natural log does that. When you have E, you want to use natural log. The reason you want to use natural log is because if you remember, natural log is the same as log base E. So if we had the natural log of E, the natural log turns into log base E of E, and log base E of E is equal to 1. Because why? To give it a swirly, it makes perfect sense. E to the first is equal to E. So that cancels out, which is super nice. Our 2x drops down in front times the natural log of E, which we just talked about, is 1. So I have 2x equals the natural log of 25. I'm going to go ahead and divide by 2. And then I can plug that right-hand side in my calculator. Natural log of 25 divided by 2. Watch your parentheses. Please make sure you get the natural log of 25, not 25 halves. And we get 1 point. That's going to be 609. Again, the 10,000th place is not 5 or more. So we keep it the same. You don't round down, you keep it the same. All right. A few more. These ones are a little different because they actually want your answer in simplest form with logs. So you will have to pay particular attention. So on this one, they tell us using common logs. So that means I'm going to use plain old log instead of natural log. We want fractions when we solve this. Fractions and integers will be fine. So again, this is an exponential equation, and I need to do something to drop my power down. And to do that, I can take a log of both sides. That's going to give me x times the log of 4 equals the log of 5. And if I want to get x by itself, I simply need to divide by the log of 4. And so there'll be, in your entry field, there'll be a little log button you can push. There'll be a little fraction button you could push if you need to. So you'd push the fraction and create a fraction. You push your log button, and you'd want to write the log of 5 over the log of 4. Works really great. You can also not use the buttons. You can actually type the word log. If you have a keyboard, you can type it, and I like using my keyboard if I can. All right, last one here. They want you to use natural logs since it's base E. So we're going to have a natural log in there, and we want fractions and integers. So again, I have my x way up high in this exponent position, so I need to drop it down. And to do that, I can take a natural log. This is where it's going to be quite tricky. You're dropping the entire power. So remember, the whole exponent gets placed in parentheses times the natural log of E. Oh man, there are some other questions that are quite challenging. This one is not going to do it. I'm going to have to make one up for you. Okay. Equals the natural log of 5. The natural log of E, we know, is just 1. And so I'm left with 4x minus 3 equals the natural log of 5. And then I need to solve for x. I'm going to go ahead and add the 3. So 4x equals the natural log. This is just the natural log of 5. And then we're going to tack on a plus 3. And I need to divide each term by 4. And So that's going to be the natural log of 5, all divided by 4, plus 3 divided by 4. And this is a perfectly acceptable answer that you can have in your IXL. It should be fine. I did want to give you one I saw when I was practicing. So D.2. Let's pretend that was a 2 to the 4x minus 3 equals 5, because I saw some like this when I was working on them. So again, I want to use, well, in this case, they're going to ask for common logs. So I'm going to take a common log of both sides, and that's going to allow my power to drop down in front. So my power, 4x minus 3, times the log of 2 equals the log of 5. Now, there's a lot of things you could do, but I will say the easiest thing to do is go ahead and instead of distributing the log of 2 and creating a big hot mess, I'm actually going to go ahead and just divide by the log of 2 right off the bat. So I'm left with 4x minus 3 equals the log of 5 divided by the log of 2. Do not cross out the logs. They're not numbers. You cannot reduce them. And then we're going to go ahead and add the 3. Tack it on the end there. And so I have 4x equals the log of 5 divided by the log of 2 plus a giant 3. And I'm going to go ahead and get rid of this 4. And the easy thing, I have to divide everything by 4, but that gets a little complicated here. The easy thing to do is to multiply everything by 1/4. Also the same equivalent thing. And so that turns out that we'd get log of 5 over 4 log 2 plus 3 times 1 is 3. 1 times 4 is 4. And this is a great answer that I typed in many a times on IXL. So that was a good one. All right. Hopefully that's a good review of solving exponential equations using logarithms. Now we want to solve log equations. We have two methods. One is you might need to condense a log like we have here. Or we have the one-to-one property where you have a log equal to a log. So we're going to go ahead and solve. You do need to simplify your answer. And probably a good idea to check. Remember, you cannot take the log of a negative number. Cannot have log of a negative number. Inside the argument is not allowed to be negative. It could possibly be our answer is our value for x is negative. Sometimes it works and sometimes it doesn't. So you do really have to pay attention. The first thing is I noticed that I have a log minus a log here. And so I need to condense that using our quotient property. I can condense it into a single log. Log base 4 of t divided by 1. Well, that was really unnecessary because it turns out the log of 1, 4 to what power is 1? It's really 0. So we could have just simplified it first, but that's okay. This t divided by 1 is just t. So I have log base 4 of t equals 2. And ladies and gentlemen, how do you drop a log? You give it a swirly. So you start with the base, you circle around and pick up your power, and it equals your argument. You convert to exponential form. 4 squared is 16, and that is our answer. You can plug it in and check if you wanted to. Log base 4 of 16. 4 to what power gives you 16? 2. 2 minus 0 is 2. Totally works. So 16 is the answer. Here, this is the one-to-one property. The one-to-one property, if log base b of u is equal to log base b of v, then u is equal to v. If the logs match, the arguments must match. 4y must equal 3y plus 12. I can go ahead and subtract 3y and get y equals 12. And if I plug that in to check, it seems it's going to be just fine. The log of 48 is equal to 36 plus 12 is also 48. Log of 48 equals the log of 48, totally true statement. Right, to get a little more complicated times. Again, this is the one-to-one property once again. So since the logs match, the arguments must match. Negative 3t minus 2 must equal negative 8t minus 12. I'm going to go ahead and add the 8t over here. That's going to give me 5 t's. I'm going to go ahead and add 2. Adding 2 over here gives me negative 10. And then divide by 5, I'm going to get t equals negative 2. Well, I definitely want to check that and see what happens when I plug it in. So I'm going to just do a little check here. Log base 5 of negative 3, plugging in a negative 2 minus 2. I really need to make sure that this is not a negative value. Negative 3 times negative 2 is 6 minus 2 is 4. That is okay. That is a positive 4. That's good. Over here, I want to make sure that that works as well. Negative 8 times negative 2 minus 12. That would be 16 minus 12, also 4. So log base 5 of 4, they are definitely equivalent. So this answer works just fine. Even though it's negative, when you plug it in, it gives us a positive argument. The stuff inside the logarithm is positive, and that's what's important. All right, over here, again, we have a log equal to a log. This is the one-to-one property again. If the logs match, u squared minus 4u must equal 5. This is quadratic in form, so I'm going to make sure that I set it equal to 0 to solve. So I'm going to move the 5 over. U squared minus 4u minus 5 equals 0. And then double bubble to solve. U times u is u squared, negative 5, and positive 1. It will give me a negative 4. That's u equals 5 or u equals negative 1. I'm going to go ahead and double check those and make sure that they both work when I plug them in. So log of, I'm really worried about the negative here, so I'm going to do that. Negative 1 squared minus 4 times negative 1 is supposed to equal the log of 5. Let's see, negative 1 times negative 1 is positive 1. Negative 4 times negative 1 is positive 4. And, well, definitely the log of 5 equals the log of 5. If we plug in 5, we would have 25 minus 20, which would give me 5. So log 5 equals 5. So they both work. They're both answers that are perfect. And I think when you plug it in, 5, comma, negative 1, they tell you to separate it with a comma. All right, ladies and gentlemen, hopefully that's a good refresher on solving logarithmic and exponential equations. That's everything all in one whole unit in one lesson. That's cool. In 18 minutes and 30 seconds. Yes. All right, ladies and gentlemen, this is for skills F10 and F12, and have fun.